A spinning magnet is levitated via magnetic repulsion above another magnet and stabilized by gyroscopic effect. Spinning top acts as a gyroscope and prevents its toroidal magnetic field from fully aligning itself in the same direction as that of the supporting opposing field of the magnetic base. Diamagnetism refers to weak repulsion between a diamagnetic material and magnet regardless of its poles. A second magnet can be used at a fixed distance to offset some of the magnet's weight. It is then possible for the diamagnetic effects to support the remaining mass of the magnet and so achieve stable and passive levitation. Pyrolytic graphite is the most diamagnetic substance known to man. A thin enough piece of pyrolytic graphite will levitate over a magnetic array. The diamagnetic repulsion is greater than the weight of the graphite. The amount of lift is proportional to the density of the magnetic flux around the graphite. In an array, this can be prominent right at the edges where the north and south are making contact. This also acts to stabilize the graphite, keeping the piece from falling off the array, assuming the array and magnets are appropriate sized. This effect can also be used to create a track that the graphite can follow. Diamagnetic apposition and suspension levitation can be combined. This form of diamagnetic levitation can hold more weight than just a diamagnetic suspension or opposition levitation. The levitation is achieved by cooperative action between large attracting ferrite disk magnet and repelling electromagnets that are controlled by a feedback loop which continuously adjusts the electromagnets in relation to the levitating magnet's position. It is possible to levitate a magnet in the proximity of a conductive material like copper or aluminum by manually adjusting another magnet above. The levitation is made possible by eddy currents. Those currents produce their own magnetic field that resists movement of the magnet. This dampens the system, slowing the movement of the suspended magnet. Using a levitation coil, a conductive object can be levitated in a magnetic field. Depending on the metal and power setting, you can even boil metals in mid-air. Aluminum will levitate and melt easily at 1 to 1.5 kilowatt of input power. When a magnet is spun at certain RPM rate, it is possible to levitate another magnet under it. The spinning magnet attached to a power tool locks the levitating magnet at a distance of about 5 to 10 millimeters. The levitation gap can be adjusted by changing the rotation speed. Faster RPM means a smaller levitation gap. The tractor beam effect is also much tighter with higher RPM. Copper isn't necessary for the effect, but it helps to stabilize the magnet. When this yttrium-barium copper oxide POC is chilled down below its critical temperature with liquid nitrogen it becomes a superconductor and magnetic field lines are expelled from its body. Magnet is able to levitate over the superconductor, but it is held in place only weakly. This superconductor is slightly different. There are small impurities on its surface which allows magnetic field lines to run through them. When cooled down to its superconducting temperature, those field lines become trapped. This locks the magnet in space above the superconductor. The magnet and the superconductor don't want to move relative to each other.